Welcome to week 12 of Operations Management course. This is the agenda for this week. First, we will be doing a quick review of week 11, and during our Zoom meeting, we will be solving the following 4 questions. And internal assessment for this week, that is internal assessment 8, will be available today. And the deadline for the submission of the internal assessment 8 is the 5th of April at 11:59 p.m. The focus of this video or presentation is to discuss about the second part of forecasting and to introduce the transportation models. And we will also be solving a couple of questions once we finish the forecasting model part 2. Those questions will be taken up in our Zoom meeting. So this is a quick review of what we did in the last week. So in the last week, I said there are 2 different types of forecasting. One is the qualitative forecasting and the other one is the quantitative forecasting. And qualitative forecasting was part of your internal assessment 7. So in quantitative forecasting, we covered the following methods. The first method is called as the naive approach. The second method is called as the moving average approach. In moving average method, we solved the questions based on either the simple moving average or the weighted moving average. The third method which we discussed last week was the exponential smoothing method. So in exponential smoothing method, this is the formula which we have used for solving the exponential smoothing method. So the formula is as follows. It says ft equals ft minus 1 plus alpha times at minus 1 minus ft minus 1. So if we are looking to predict, say, the forecast for the month of May, I need to have the forecast value for the month of April plus the actual sales for April and the alpha. Alpha is the smoothing constant. So the information should be given to us in the question for using the exponential smoothing method. And once we finished solving questions using these 3 methods, I introduced what is referred to as the forecasting error. So forecasting error typically represents the difference between the actual value and the forecasted value. And I said the forecasting error can be measured in 3 different methods. First method is called as MAD or mean absolute deviation. The second method is called as MSE or mean squared error. The third method is called as MAPE, mean absolute percent error. So we will be solving some questions based on these concepts during our Zoom meeting. Now going forward, so to give a quick review of this, the questions were typically looking like this. You will be given, so for instance, in this case, the data for the first 4 quarters is given and the actual tonnage is also given. Please note that the first month forecast or the first quarter forecast should be given to you. In this case, it is given as 175. You are also given the value of alpha equals 0.1. So let me just demonstrate how to use this equation for estimating the forecast for second quarter. So for the second quarter, so let me use a blue color. So for instance, for the second quarter, F second quarter equals the forecast for the first quarter, which is 175 plus alpha times alpha is 0.1 times AT minus 1, the actual sales for the first quarter, which is 180 minus the forecast for the first quarter, which is 175. So if I sorry for my handwriting here. So if I try to substitute it here, it will be 175 plus 0.1 times 5, which is 0.5. So I get my number as 175.5. So this is the forecast for the second quarter. So using this method, we can do is the same way we can do for the third quarter, fourth quarter, and so on. So last time we did questions in Excel using this same formula. Now, just to quickly summarize, what we have studied is, in quantitative methods, I said the focus will always be on situation which is stable. So if you are looking for an existing product, or if we already have past data available, we will be going ahead with quantitative methods. So this method is used for existing products or for the current technology. And we have already finished naive approach, moving average approach, and exponential smoothing. So the focus for this particular lecture is trend projection and linear regression. We will start with the trend projection method. Please note that trend projection also falls under the time series model. So what time series model represent is, so these are typical methods which are used for predicting the forecast for a certain period of time. However, linear regression is slightly different. So that's called as an associative model. I will explain more about the associative model once we are in that particular slide. So for the time being, we will start with the trend projection method. So let's see what is trend projection. So trend line represents, so the trend projection is a method used for fitting a trend line to the historical data points. So if we are trying to look at our historical information, and if we are trying to see how the data is looking like, and if we are trying to analyze the trend of the data, that's when we are going to use the trend projection method. And once we are able to identify the trend from the past data, we will be using that knowledge to estimate the forecast into the medium or long range. So let me explain how the trend projection method is typically used. So we will be using the following equation: y hat equals a plus bx, wherein x is representing an independent variable. A and b are two different parameters which we need to estimate, and y hat represents a predicted value. So please understand that what we are trying to find out is an equation of this particular form: y hat equals a plus bx. So we need to, so wherein x is called as a independent variable and y hat is called as a dependent variable. Let me explain, let me give an example in the next slide what a dependent and independent variable looks like. So let's look at this particular figure. So in this particular case, in the x-axis, I have data for every third day, for every single day. For instance, it is showing the 2nd of August 2008, 5th of August, 8th of August, and so on. I have the information, and I know that how many. So y-axis is representing the sales, and the dotted points are representing my actual sales each day. So the dotted points are the actual sales, and the x-axis is that particular day. So the independent variable here is the time, which is the day which we are looking at, and the dependent variable is the sales. So sales is the dependent variable, and independent variable is the day in which, or that particular date which we are looking at. Now what it says is, in order to, so what we are looking at is based on these, so you will be given information on these points. Based on these points, we are trying to find a method of drawing a line as shown by this red thing. So this red line represents the trend line. So my focus is, once I have this dotted points available, how can I fit a trend line as shown in this particular figure? So for drawing this particular trend line, I use a method called as the least square method. So if you have not heard of this least square method, I will first explain what it means, and then I will demonstrate how to use the least square method for estimating this particular line. So least squares method is a method which minimizes the sum of the squares of the difference between the line and individual data points. So let me explain it clearly. So if you're trying to, so let's say that if you're trying to fit a line through each of these points, for instance, let me use a green color. Let's say that if I'm trying to connect all these points using a line as I'm showing, so you will be getting a fluctuating line, and it doesn't help in predicting anything. So rather than fitting a line through each of these points, what we are trying to look at is, we are trying to come up with a certain line called as the trend line, such that that's like an average line. When I say that average line, what I mean is it will not, and it will never be going through each of these data points. The trend line will never be passing through each of these data points, but what will happen is, I can say that the distance, if I try to find, so for instance, for each of these points, if I try to find the difference between the data point and this particular point on the line, if I try to find the difference, that's the deviation, just like what we calculated in our forecasting error. So assume that if I'm finding the deviation for each of these points, and then I try to take the square, just like the MSE method, the mean squared error. So that's what it's saying. So if I'm trying to find out the mean squared error, so for each of these points, and try to add that particular thing, it can be shown that this particular line will be giving the lowest error. So the least squares method is a method which helps to minimize the sum of the squares of the difference between the line and the individual point. So this is similar to, so this is pretty much similar to, so I'm just highlighting this. So the sum of the squares of the difference between the line and the individual data points. So what it is saying is this is like just like MSE we have seen similar to. So this is similar to the MSE method which we used for estimating the forecast errors. Now let me show how this has to be calculated. So for instance, from the previous diagram, our x-axis was the time period and our y-axis is the sales, for example. That's the value of the dependent variable. Now for each of these points, so each of these start points, I try to find out the deviation error. Then try to take the square of that deviation error. Try to add the deviation for each of these points. The trend line will always help me to minimize the sum of the squared errors. So the trend line is estimated using this particular equation, y hat equals a plus bx. So let's try to see an example for this particular method. So you are given for each year, say for instance from 2006 to 2012, the electrical power demand is given for each year, and you are asked to find what will be the demand for the next year. For instance, we have data till 2012. We are interested in finding the forecasted electrical power demand in 2013. So what we first do is, so let me show how to do this particular thing. So what we are asked to find is an equation like y hat equals a plus bx is the thing which we are interested in estimating. So I will be showing how this is calculated in this presentation, and while we discuss this in our Zoom meeting, I will be demonstrating how we can calculate this using Excel. So the first step is each of these years. So I need to first find, so 2006 is my first year, 2007 is my second year, third year, and so on. So the first thing which I am doing is I create a time period which is the independent variable. So the time period here, x, is the independent variable. So this is my independent variable. I represent that by say IV. IV represents the independent variable, and the electrical power is the dependent variable, dV, dependent variable. I am trying to find out a relationship between the dependent variable and independent variable using this equation. I am looking at an equation like y hat equals a plus bx. So if you want to find the variables a and b, this is the equation which you should be using for estimating this particular equation, wherein b is given by this particular equation, sigma xy minus n times x bar y bar divided by sigma x square minus n times x bar square. I know that it can be a bit lengthy to calculate, and once you estimate the value of b, you can use this equation for a, wherein a equals y bar minus b times x bar to estimate the value of a. So please understand, we just repeating once again, we are given the value of x and y. We are looking at a method for estimating the equation shown here, y cap or y hat equals a plus bx. So if I am able to find a method for that, wherein I need to then have an expression to find a and b. So the expression for b is shown here and the expression for a is shown here. So if I am able to find these two variables a and b, if I substitute it in this equation, I get a nice trend line. So let's look at what are the variables which I need. If you look at the equation for B, you can see that you need x bar, y bar. X bar represents the average of x, which is 1 plus 2 plus 3 plus 4 plus 5 plus 7, 6 plus 7 divided by 7. So that's the x bar. Y bar represents the average of the y values. So we need definitely x bar and y bar. We need a column for x, y. So if I create a table for column for x, y, I will be able to add those columns called as sigma xy. I need a column for x square for this particular calculation. So let me show how the numbers are looking like. So if you look here, so for each year, so the first step is I estimate that the time period is 1, 2, 3, 4, etc. And my demand value y is also shown here. So the first step is to calculate x bar equals sum of this, the average of these numbers, right? So x bar is the average of these numbers. So it's the average is the x bar. So x bar is obtained as 4. Y bar is the average of these numbers. So the average of these numbers is coming as 98.86. Now once I estimate x bar and y bar, my second thing I need is x square. So I create a column for x square here. So 1 squared is 1, 2 squared is 4, and so on. I create a column for x square. Now I add the values of x square, which is 140. So that way I get all these numbers. My next step is to find, if you see here, I need an equation for x, y. So I write x, y here. So x times y. So 1 multiplied by 74 is 74. 2 multiplied by 79 is 158, and so on. Then I add these numbers. So the sigma xy is the sum of these numbers, which comes to be 3063. So once I estimate the following things, so x bar, y bar, sigma x square, and sigma xy, I can substitute these values in the equation for B. So if I substitute the values in the equation for B, I get the value of B as 10.74. Once I get the value of B, I can go to the equation for A and estimate the value of A as y bar minus bx bar. I get the value of A as 56.70. So now I have estimated the values for A and B, and now I can easily write my trend line as follows. So based on this data, my y hat equals A plus bx will turn out to be 56.7 plus 10.54 times x. So this is my trend line. So this is my trend line. So if there's a question on estimating the trend line, so this is exactly what you will be doing to estimate the trend line. Once the trend line is obtained, this question is find the demand for the month or for the year 2013. I know 2013 is the 8th time period. So 2013 is the 8th time period. I substitute it in this equation and I get the value of y hat as 141. So this method is called as the trend projection method, and we are using least square approach to estimate the trend line. So the least square approach helps us to calculate the variables a and b. So the equation which we were seeing for b, and then we will substitute the value of b into a, so thus finding a and b. This method is called as a least square approach. And once you get the value of a and b, you get a nice trend line equation, and you can find the forecast for any year. So if the question is what is the forecast for 2014, so 2014 will be, so let me use another color. So let's say for 2014, if the question is 2014, my time period will be Nyan. So, and I substitute the value of the Nyan in this particular equation to estimate the forecast for the month, for the year 2014. So the next thing is some key points I want to mention about the least square approach, which we just used for estimating the value of a and b. So always remember that you need to first plot the data, and since we have been using a linear approach, the least square method is always assuming a linear trend. But if your data is not looking linear, that means you can never use this particular method. So please remember that the least square method can always be used only if the trend is looking like a linear, is looking linear. If it is not looking like a linear one, the least square method cannot be used. So just keep in mind. The second thing is never predict too far into the future. What it means is, say, let's say that you have information in the previous case for the first, say, 7 years. It is okay to predict it for, say, the 8th year and 9th year, and maybe max till the 10th year, but not like, say, with the information for the, say, first 7 years, you shouldn't predict that forecast for the next, say, 20 years or so. In that particular case, the accuracy of your forecasting model will be questionable. And the second thing is, we are assuming that the deviations which we are seeing is assumed to be random. That's what we are assuming when we are using this approach. So I didn't show how we actually derived that particular equation, which is not needed for you. But when we are deriving an equation for this a and b, we are actually making an assumption that the deviations are random. So if these three key things you should always remember, at least for your situation. The first two things are very important. So this shows the disadvantages or the advantages of the least square method. So if you see that the trend is not at all linear, please don't use this method. And don't try to predict too much far into the future. It may not be very accurate. Now we just finished the trend projection method. Let me go to the next method called as the linear regression method. Linear regression method is coming under associative model. It's coming under the big umbrella of associative model. Let me explain what it means. So this method is similar to the previous method. This method is exactly same. I won't say exactly same. It is similar to the previous method. In this method, you are trying to predict the changes in the dependent variables based on the changes in the independent variables. So x was our independent variable. So based on the changes in x, we were trying to predict the change in the y. That's exactly what we did in the previous case. Now, if it's the similar thing. So let me show the equation. So the linear regression is the most common thing. It is same as the least squares method, wherein we still use the same equation, y hat equals a plus bx, wherein x is the independent variable and y is the dependent variable. So this is still the same as the trend projection. And if that's the case, what's the difference between, there's always a question, what is the difference between the trend projection and say linear regression? So let me show that in the next slide. So before going to that, please understand there are different types of regression approaches. So the easiest one is the linear regression, similar to the least squares method. There is another method called as the multiple regression. So in multiple regression, instead of a single variable x, we are considering multiple variables, multiple independent variables, say x1, x2, and so on. So if you have multiple independent variables, you may like to use a multiple linear regression. So the equation will look like y hat equals a plus b1 x1 plus b2 x2 plus etc. So this method can become trickier if you are trying to solve it in Excel, but there are many programs which can solve any number of independent variables. So this is not part of your syllabus. So multiple regression is something which you need not have to worry about at this point of time. So let me take an example to demonstrate how the linear regression is different from the previous method. Previous method was the trend projection. So let's say in this case your dependent variable is the sales in $1 million is given, and if you see here, your x-axis or the independent variable is the payroll in billions. So let's say it's an payroll is the independent variable. So if you see here, it's not the time period. So what this method is trying to predict is the relationship between two different aspects of business. One aspect is the payroll, which could be, let's say, in terms of salary or whatever things, and y-axis is the sales for a particular product. So we are trying to find the relationship between payroll and sales. So in the trend projection method, we were always trying to find our x variable was always the time period, and y variable was whatever sales or whatever we are interested in finding out. But in linear regression, please understand that we are trying to find the relationship between two different variables. Let's see how to calculate that. The calculation is exactly same as the least squares example. So if you have x, you have y. You first find out x bar. You need to find out y bar. You need x squared and you need xy. So these are the four things which you need for calculating b. So when I substitute these values in b, I get the value of b as 0.25, and when I substitute the value of b in the equation for a, I get the value of a as 1.75. So what it means is y hat equals a plus bx equals 1.75 plus 0.25 times x. So we have now got, so what it means is I got a relationship between the sales and my payroll. So if I have some information on the payroll, I can always find the relationship for sales. So as a calculation method, this is exactly the same as your previous thing, but the only difference is in trend projection our x is always time period, but here it can be any variable. So I will demonstrate the calculation of this in our Zoom meeting. So going forward, so since I have an equation that connects the sales and the payroll, so let's say that if the payroll is estimated at say 6 billion next year, what will be my sales forecast? So just substitute the value of X, where X is the payroll. If I substitute it here, I will get the value for the sales. So calculation is similar to the trend projection. So here also remember that the forecast is a point estimate of the future value. And I'm not going to explain much on this aspect. So the point is we are trying to find out. So for the year 6, I'm trying to say that my value is gonna be say 3.25 million. So this is what I'm just trying to see. Plus always remember that it need not necessarily be exactly 3.25 million. There could be a fluctuation in the prediction, which we are not going to do in our course. But remember that we just find a point estimate. Point estimate refers to a single point in the future is what we are doing, but there can be a fluctuation in the result. That's what it is saying. But for your examination point of view, the thing which you need to understand is how to use the equation y hat equal to a plus bx. How should you calculate a and b? And then if you want to calculate the forecast for any year, how will you use the equations? So this is enough. Now once you calculate a plus bx, in the case of linear regression, there are some other things which we can definitely use. So the first thing is called as a standard error of the estimate. So as I was showing in the previous slide, I was saying the point which we are predicting or forecasting is just a point estimate. There could be error associated with that estimate. So for identifying or for calculating the standard error of that estimate, we use this particular equation. So since your examination is going to be an open book examination, all these formulae will be available to you. So please make sure that you are using the equations appropriately when you are calculating the things. So if you're trying to, so I always recommend that you note down the formulae in one particular section so that you can just refer to that particular formulae when you are solving your examination. So when I substituted, I get the value of SYX as 0.306 million or $306,000 in sales. So this is the error that is associated with my estimation. So this is very important. This is similar to the forecasting error which we were doing. Now next thing which we normally measure is called as the correlation coefficient. So the correlation coefficient is a method which helps to find the degree or strength of the linear relationship between the variables. So what it means is I use the equation y hat equal to a plus bx, but I want to see whether the relation is actually linear or how much is that linear relationship between the variables. So it says, we always say that the correlation does not imply causality. So what it means is, if we find that there are two different variables which have some correlation to each other. So let's say in the previous case, we found that the payroll and sales have some correlation to each other, but that doesn't mean that the payroll is creating sales. So that in conclusion should never be drawn. So please understand that the correlation between two variables does not necessarily imply that there is a cause effect relationship. Now, to identify the coefficient of correlation, we use this equation. So the equation, I'm not reading out the equation. Please note that if you substitute the value of xy, sigma x times sigma y and so on in this equation, you will get the value of r. If the value of r is closer towards 1 or closer towards -1, it means that there is a strong correlation between. So this is something which I want to highlight. So if r equals, say, r is equal to, say, 0.8 or more, if I calculate, and if I find that the value of r is 0.8 or more, that means that there is a strong correlation. So this implies there's a strong correlation between, the relationship between x and y is very, very strong. If I get r as -0.8, even then it means that the correlation is strong, just that they are negatively correlated. So the value increase in x, if r is obtained as negative, it means if the value of x increases, my value of y will reduce. So please remember, in linear regression is a sure shot question for your final examination. In linear regression, the things which we calculate are as follows. The first thing is, given the data, we first need to find out the equation for a and b, and then write the equation y hat equal to a plus bx. The second thing is, you might be asked to find a forecast for a particular value of x. So this is the second thing which you will be doing. The third thing is finding the standard error of that estimate. The fourth thing is the correlation coefficient, and you may be asked to find whether the correlation is strong or not. So just look for the value of r. If r is greater than 0.8, you can say that the relationship is very strong. Now going forward, so this is the next module, so called as the transportation models. So I will be discussing about the transportation models for the next 5 minutes. So we are not having any numerical questions from this particular topic. So this is just for our understanding purpose, how transportation plays a very important role in operation management decisions. So the objective of the transportation model is to minimize the cost associated with moving goods. It can be either finished goods or it can be raw materials between two different locations. The objective is always to come up with the best strategy for moving materials from one location to another. So always remember that this is an iterative procedure wherein we find the lowest cost for moving items from one location to another, and there are multiple methods which are available for doing this particular thing. So what we need to know in each case is, what is the capacity available at each end, or the supply available at each end, what is the demand needed at each location. So I know my supply, I know my demand at each location, and then what is the cost associated with shipping 1 unit of material from the supply location to the demand location. So I need to have these three information in my transportation modeling to come up with the lowest cost. So let me show an example here. So in this particular case, we are given, for instance, A, B, and C. Here A, B, and C are the locations where there is a demand, and D, E, and F are the locations where you have your material. There is a supply of this material. So if I want to, so what it means is $5. So let me say, if I want to move 1 unit of material from D to A, I need to spend say $5. But if I am shifting a material from say F to C, again I will be spending $5. So that's what this particular table is representing. And assume that I know the demand and supply at each location. So we have 6 different locations now, A, B, and C. So it says for A, 300 units is required, B, 200 units is required, and C, another 200 units is required. So these are the demand locations, A, B, and C, shown by the blue colored thing. And D, E, and F are the locations which are like the factories wherein the things are being manufactured. So D can supply 100 units, E can supply 300 units, and F can supply another 300 units. So I try to now put all the information in a single matrix as shown here. I'm just showing that say A, B, C are my demand locations. I know that the demand is shown here. For A, the demand is 300. For B, the demand is 200. And for C, the demand is 200. And D, E, and F are my supply locations. So the supply at each location is also given. Now 100, 300, and 300. Now the cost associated with shipping 1 unit of material from say each location from D to B is $4, D to C is $3, and so on. So this is also given to you. So if you have this sort of a framework available, there are multiple methods that can be used for calculating the transportation model. We are not solving these questions, but what I want you to understand is the framework of any typical transportation model. You will have the demand locations, you will have the supply locations, and you will also be having the cost associated with each location. So if this information is given, you should be able to calculate, you should be able to use an appropriate transportation modeling method to find the best strategy. So just to say that the name for 2 different methods, it's called as northwest corner rule and intuitive low cost method, are 2 different methods which can be applied. So these are not the best methods, but these could be the starting points when we try to look at an operations management decision with respect to transportation. So please remember that there is no numerical question from this, but we need to understand just the framework in which things are looking like. You don't need to know these methods for the examination, but there could be a question on asking, how does the transportation model look like? So if the question is asking, you need to know that it should have the demand locations, it should have the supply locations, as well as the cost associated with shipping item from each of the supply location to each of the demand location. So we need to have these 3 aspects in our transportation model, and some example like what I just showed previously can be used for demonstrating it. That's it. So with this, we are coming to the end of today's lecture. Thank you so much.